This video is about half-life. Earlier we learned that during radioactive decay, parent nuclides decay into daughter nuclides. Let's add to this that radioactive decay is random and spontaneous. Imagine that we have a large sample of nuclides. The term random here means that it is impossible to predict when a particular nuclide will decay. We also say that the decay is spontaneous because it is impossible to influence or modify the decay in any way. The way to measure radioactive decay is by using a Geiger-Müller or GM tube and counter. Here we won't discuss the details of how such a device works. Just keep in mind that it is used to measure radioactive decay. Radioactive material is found everywhere around us. This radiation is not harmful to humans, but can still be detected. The term background count means naturally occurring radioactive decay as measured by a counter. A key point about radioactive decay is that if we have a large sample of radioactive nuclides, we can predict with high accuracy the number of nuclides that decay in a given amount of time. One way to express this concept is by using the idea of half-life. Half-life is defined as the time it takes for half of the parent nuclides in a sample to decay. Let's see an example to understand half-life better. We'll work with mercury-210. Its half-life is 10 minutes. Let's say that we have a sample that contains 100 such nuclides. Since the half-life of this nuclide is 10 minutes, after 10 minutes, the sample will have 50 mercury-210 nuclides left. The other 50 nuclides have decayed. After another 10 minutes, so a total of 20 minutes, we would have half of these nuclides, so 25 remaining in the sample. We can also express the remaining amount of parent nuclides as a percentage. Let's create a table to show this. So as you can see, in the beginning, when time is equal to 0, 100% of the parent nuclides are undecayed. After one half-life, so 10 minutes, this amount is halved and only 50% remains. After another half-life, so 20 minutes, 25% remains. After 30 minutes, this amount is 12.5%, and after 40 minutes, 6.25%. In questions, you will often come across radioactive decay graphs. Let's see how such a graph looks like for this decay. We have time on the horizontal axis and the percentage of undecayed parent nuclides on the vertical axis. This is what we get when we plot the points based on the table. And here is the decay curve after we connect the points. An important point to keep in mind when you're trying to find a half-life from a decay curve is that half-life is found at the point where the percentage of undecayed parent nuclides is 50%. So here, if we would only be given the curve without any other information, we could still determine that the half-life is 10 minutes. This wraps up our discussion about half-life and completes the final video of subtopic 7.1. In the first video of subtopic 7.2, we will learn about the stability of nuclides.